All right, hello again, everybody. Today we're going to start thinking about how we can divide two polynomials by each other. But first, I think it's going to be beneficial to do a quick review of long division. So we learned long division back in elementary school, but we haven't done it for a while, what with having calculators and such. So let's just go through a problem real quick to refresh our memory about it. So this says divide by using long division. So we're going to take 2,174 divided by 3. So if you remember from elementary school, we would write our 3, and we'd make our little box here, and we put our 2,174 inside the box. So this number goes inside the box, and this number goes outside the box. So now what we'll do is we'll take our 3 here, and we'll see, well, how many times does 3 go into 2? Well, it doesn't go into 2 at all. So we'll now look at the next term. Instead of just considering 2, we'll consider the whole 20, the 2 and the 1 as 21. So how many times does 3 go into 21? Well, 3 goes into 21 7 times. So we'll take 3 times 7, and that's 21, positive 21, and now we'll flip our sign, subtract it from the original 21, and now we have 0. Now we'll take our next number, 7, and we'll bring it down. So how many times does 3 go into 7? Well, 3 goes into 7 twice, because 3 times 2 is 6. If we put a 3 there, it'd be 3 times 3 is 9, which is greater than 7. So we have to be less than 7 still, so we'll have 6. So 7 minus 6 is 1. Now we'll take this 4, and we'll bring it all the way down here. So we'll have 14. And how many times does 3 go into 14? It goes into 14 4 times. So 3 times 4 is 12. Flip our sign again, and now we're left with 2. Well, 3 can't go into 2 anymore. So instead of coming up with a decimal for it, we're just going to write this as remainder 2. So our answer in this instance will be 724 remainder 2, and or we could rewrite that as 724, and we'll take our remainder here, this 2, and put it over the 3. So 724 remainder 2/3. And we can check if this is right real quick by taking our 724 and multiplying it by 3. So 724 multiplied by 3 real quick is 2,172. But now we have this remainder 2 that we'll add on to the bottom. So we add our remainder on, we don't multiply it. So it's 2,174, which is what we started with. So we did get the right answer. I think it's also beneficial to review a monomial versus a polynomial. So a monomial is a number, variable, or expression that is the product of one or more variables with non-negative exponents. So some examples of these would be like 9x cubed y to the 7th. Because these are non-negative exponents and it's the product of some certain variables or expressions and variables. It could also be something as simple as x squared, that's a monomial. Y, that's a monomial. Even something like 7 could be a monomial. However, a polynomial, on the other hand, is an expression of more than 2 algebraic terms, especially the sum or several terms that contain different powers of the same variable. So this is where we take the sum of different monomials. So this is like 3x squared plus x plus 1. We're summing up different algebraic terms. It's not just one term. So, or it could be, x squared y to the 3rd plus x to the 7th, y to the 5th. It's the sum of those algebraic terms. And so let's figure out how to find the degree and leading coefficient of a polynomial. So to find the degree, we just look at the monomial in our polynomial that has the highest exponent, or the highest degree as we'll call it. So with this first example here, we look at which exponent is the largest, and in this instance, it's our 5 right here. So the degree of this polynomial is 5. And then the leading coefficient will be the coefficient of the term with the highest degree. So since the coefficient of this term is 3, our leading coefficient, which I'm going to abbreviate as LC, is 3. So if we look at this example over here, x squared minus 4x cubed plus 1 minus 3x, in this instance, it's not arranged in descending order of power. So just because the x squared comes first does not mean that it's going to be the highest degree. In this instance, we have this x cubed right here. 3 is greater than 2, and it's also greater than 1, and this would be x to the 0. So this is the degree of our polynomial. It's 3. And so the leading coefficient, it's not going to be the coefficient on the term that comes first. It's the coefficient of the monomial with the highest degree. And in this instance, it's going to be -4. So if we look at this last example down here, let me bring it over here real quick. So we have 2x squared y minus 4xy. So we know that these all have exponents of 1, the ones that weren't explicitly stated. So in this instance, to find the degree of the given expression, since these are being multiplied by each other, the degree will be the sum of their exponents. So if we look at this first term, 2x squared y, since the sum of the exponents here is we have a 2 on the x and a 1 on the y, so the degree of this term is 3, whereas our 4xy is just 1 plus 1, which is 2, and that's the degree of the second term. So the degree of this polynomial is 3, because 3 is greater than 2, and the leading coefficient is going to be 2. So last time we touched on it a little bit as well. With our exponent rules, we could divide two monomials. And so to do that, if you remember, what we could do is we'll look at our numbers first. So we have 9 over 3. So we know 9 divided by 3 is just 3. Then we can look at how many x's we have on top. So we have 3 x's on top, 2 on bottom. So 2 of the x's on top will cancel with the 2 x's on bottom. And so we're left with just 1 x. And we can do the same for our y's. 2, 3, 4, 5. Well, 2, 3, 4, 5. There. And so 5 of our y's on top will cancel with our y's on bottom. And so we're left with a y squared on top. And so we know how to divide monomials from our exponents days. But now we can also divide a polynomial by a monomial. So if we look at, there we go. If we look at this example right here, since we have addition and subtraction on top, what we can do is we can break this up into terms, and then this 4xy will just be the common denominator for all the terms. So we can break this up into 8x to the 4th y squared over 4xy plus 16xy to the 5th over 4xy minus 4x squared y cubed over 4xy. So we take the polynomial on top and break it up into its individual monomials. And this way we can divide each of the terms individually by the monomial on bottom. So if we look at this first one here, 8 divided by 4 is 2. We have 4 x's on top and 1 on bottom, so one of the x's on top will cancel with the 1 on bottom. So we'll have x cubed. We have 2 y's on top and 1 on bottom, so that'll be y, plus 16 divided by 4 is 4. We have 1 x on top and 1 x on bottom, so our x term will just cancel out. And then we have 5 y's on top and 1 y on bottom, so we're left with a y to the 4th. So that x term, since there's 1 on top, 1 on bottom, is just gone. And then lastly, we have minus. So we have a 4 on top and a 4 on bottom. 4 divided by 4 is just 1. We have an x squared on top and an x on bottom. So we're just left with 1x. Then we have a y to the 3rd on top and a y to the 1st on bottom. So it'll leave. And we're just left with a y squared on top. So by breaking the polynomial into its individual monomials, we're able to divide it by a monomial. And then this would just be our answer.